shown below, the switch is moved from position A to position B at a time t equals to 0. The current I through the inductor satisfies the following conditions. I of 0 is equals to minus 8 amps. The rate of change of current at t equals to 0 equals to 3 amps per second. I of infinity is 4 amps. Then find the value of R is. Here E2 equals to minus 2 di by di of t by dt minus IR. So at t equals to infinite, E2 equals to minus IR. So I of infinity is nothing but 4. So E2 is equals to minus 4R. Here at t equals to 0, E2 2 di of 0 by dt minus I of 0 is nothing but minus 8, hence 8R. E2 is nothing but minus 4R, hence minus 12R is minus 2 into 3, which is minus 6, hence R is 0.5 ohms, which is option A is correct. The network function h of s given in the question itself. So find the bandwidth and the quality factor for the given network function. Here we know that bandwidth is nothing but resonant frequency divided by the Q. Here the resonant frequency omega naught is nothing but 1 by under root 10 power 6, that is 10 power 3 radians per second, and the bandwidth is nothing but 300. So quality factor is nothing but 1000 divided by 300, which is 3.3, hence option A is correct. If lossless 100 ohm line is terminated by a load, ZL equals to 210 ohms. If the voltage at the receiving end is 80 volts, what is the voltage at the sending end? Here S equals to Vmax by Vmin, that is ZL by Z0, which is 2.1. So Vmax equals to 2.1 Vmin. Here the Zmin means it is the distance from the load end here where the minimum voltage minima is occurring, pi plus 2m plus 1 pi. Here beta is, so here this is the location where the minima is occurring. So the maximum is occurring at the sending end in the case of lambda by 4 lossless line, hence this is 2.1 into ET so this is 168 volts Vmax, which is occurring at the sending end, hence option B is correct. 100 ohm lossless line has VL is 10 e power j25 volts and ZL is 50 e power j30. Find the current at lambda by 8 from the load end. Okay, so IL, that is VL by ZL, that is 0.2 e power minus j5 degrees. Now see, this is the load end ZL. We are moving towards, if we assume this current at Z equals to 0, we are moving towards the negative side. So IL at Z equals to pi, Z equals to lambda by 8 distance is IL e power j beta L, that is IL e power 2 pi by lambda into lambda by 8, that is IL into e power 45 degrees, which is 0.2 e power j40, which is option A is correct. In an optical communication, the number of photons detected at the receiver follows a Poisson distribution with probability of k slash omega equals to e power minus omega power k by k factorial, where omega is the average number of photons per bit and k is the number of photons received at the receiver if probabilities of sending 0 and 1 are the same, and the probability of receiving 0 transmitted is 0, assuming a bit error rate is 10 power minus 9. Find the number of photons for registering binary 1, that is omega 1 we have to find out. Here, probability of receiving 0 by sending 1 is replaced by probability of 0 omega 1, which is e power minus omega 1 divided by 1. Okay, then bit error rate is probability of 0, probability of 1 slash 0, probability of 1, probability of 0 slash 1. Probability of 1 slash 0 is 0. Here probability of 0 equals to probability of 1 equals to half. Hence bit error rate is nothing but 1 by 2 probability of 0 by omega 1. Which is 1 by 2 e power minus omega 1. Here, which is nothing but bit error rate, omega 1 is natural logarithm of 1 by 2 bit error rate, so which is equals to